Oh,
All right, go ahead.
hi, I'm Doug Horn, the Crops and Soils Agent, um, based out of Augusta County. Um, I'd like to welcome you to our last fireside chat. I'll be talking about drill calibration this evening. Um, Here we go. Um, I've always been interested in calibration, and when I looked through the internet, there wasn't a whole lot available for doing the calculations. One of the worksheets I found was from Rice Tech, and you can see it's kind of cluttered on trying to figure out where to put the information, and they're showing all the formulas. But it's a good tool with the information there. It's a little tougher to read. Um, the University of Kentucky has a nice calibration video. It's about a 12-minute video that goes through the procedure, but they say, look at our chart. And you look at the chart and you have to do a lot of interpolation, or if your row spacing happens to be different, then it's a little tougher to find the correct numbers. The spreadsheet that caught my eye first was the King's Agri-Seeds. And there's this very simple spreadsheet. You enter in the row spacing and the distance you wanted to drive and your target rate, and then they would calculate how much material to collect for each row of the drill. So I started modifying that spreadsheet for my own uses and kept enhancing it. But every time I would do a calibration, I would have to recalculate and redo the formulas to make them work for each situation. So as I did more calibrations, I said, let's make this spreadsheet do the work. So I finally got it together, and it's been published on the Virginia Cooperative Extension Publications website. The website is listed there, but if you do a search for Virginia Cooperative Extension Publications, it should bring you to a page like this. Right now, since it's new, it's under the trending, so it's on the first page. You click on that icon. Well, if it's not on that page, if you type calibration in the search box, it will bring up something like this. You click on it, it brings you to where you can actually download an Excel spreadsheet that is used to do the math for your calibration. When you first download the spreadsheet, it's going to look something like this. And up in the corner, it'll say enable editing. If you do not click that, you won't be able to enter anything into the spreadsheet. The spreadsheet itself has a first page of instructions. There's also a tab for seed weight template. And then we also have a seed count template. So I'll walk through these one at a time. So once you click on the enable editing, then you're allowed to come in and change the spreadsheet. These spreadsheets are protected, so you can only put data in certain cells. If you click on the other cells, they're protected so that you will not knock the formulas out of the spreadsheet. I recommend that once you download it, to save a clean copy of the template and then make a copy of the worksheet that you can input your data and ultimately save for your records. This is a close-up of the seed weight template. You can see I've color-coded. The gray cells are for general information that is not critical to the calculations, just to help you keep track of each individual calibration. These blue cells on the left-hand side, you must enter data into all of those boxes to get the necessary calculations. So it's information like the target rate in pounds per acre, the circumference of the drive wheel in inches, the number of revolutions that you are going to turn the drive wheel. I called it number of tubes to collect, but how many rows are you going to collect your sample? And then the row spacing of the drill. Once you put those numbers in, the calculations will take place. And once you start running the calibration, then you enter your setting and the weight that you collect in the data log. And if you have a computer present during calculation, then it will automatically calculate your pounds per acre. The bottom half of the seed weight template, basically from the information above with the circumference of the drive wheel, number of revolutions, it would tell you how many feet in a linear run that would be. It just copies over the pounds per acre from above. The light yellow boxes is either the ounces or the grams per single row. Then above where you had the number of tubes to collect, it will automatically fill in and multiply it out and give you the total number for that. The blue cell that's down at the bottom, if you click on that cell, you'll see this arrow and a drop-down box. And that is for selecting whether you want to use ounces or grams. You can see here it defaults to grams. If you choose yes in the drop-down menu, then it drops down to the ounces, and then the ounces is updated in the data log to use for your calculations. This is an actual example using the seed weight template. In this particular example, I was using a hay buster drill, put in the critical information. This was a cover crop mix, target rate of 50.2 pounds per acre. The hay buster drive wheel was 62 inches in circumference. I decided to turn it 20 revolutions, and I like to shoot for about 100 feet for a distance, so that I can get a decent amount of material and little less start and stop error. And then I decided to do 6 tubes for this calibration. That drill is a 7.5 inch spacing, so you can see the numbers fill in. And since I'm using 6 rows down here, I was using grams, and then it puts grams per 6 tubes. I enter my data and get the results. With the seed count template, it looks very similar. You have the gray information at the top that's just your for your record keeping. Then there's a little bit of difference in the data you need to input. Since you're based on seed count, you need to input the seeds per pound, which is usually found on the bag. And then you would put your target seeds per acre, then the drive wheel circumference, revolutions, number of tubes, and row spacing would be similar to the other template. The bottom half of that spreadsheet, again, is very similar, but you have the extra seeds per acre that's copied from above. And using the seeds per acre and your target number of seeds, it calculates the pounds per acre that would be. This is an actual example for a seed count calibration. So here we are using a John Deere 1590 drill. I put the seed variety and supplier in there and who did the calibration. With this particular soybean, it was 3,211 seeds per pound. In mid-May, we were shooting for 120,000 seeds per acre. The John Deere had a 95-inch wheel circumference. With that larger circumference, we decided to go with 13 revolutions, and that put us just over 100 feet. Then the number of tubes, again, went with 6. The row spacing was 7.5, and you can see the data is calculated out. So for 6 rows with grams, we needed about 150 grams per 13 revolutions. So the actual data, when I run, we looked at the chart in the seed box and decided to start with setting 11. And you can see when we punched the numbers, it was only 108,000 and we were looking for 120. So we bumped up to 12, went to 115, still a little light, went to 13, we got 121. So we knew we were getting close. When I get close, I like to repeat the run to see how consistent the seed is running. And you can see it was only 3 grams difference. And so that was pretty good. So, but instead of stopping right at that point, I like to continue on and bracket my desirable rate. Because suppose you're get sidetracked planting corn or it gets wet and all of a sudden it's mid-June before you can get these beans in the ground. Well, the later you get in the season, the heavier rate you need to use. So you might want to be up at 140,000. So if you quit at 120, you'd have to recalibrate. By continuing to go, you can see I bracketed roughly 140, 160, 180. So that way I will have a good reference point to go back to in the future if I want to use a different rate. You can use this data sheet if you don't have a computer or handheld device that you can use during the calibration. You simply input all of the data, let the computer do the calculations, and then take the printed piece of paper out to your drill, write in the setting, write in the weight that you collect, and then you can compare it down to the target weight for collection. Then when you get back into the office, if you want to keep a permanent record, you can copy these numbers into your computer and it will calculate your pounds per acre and seeds per acre. Another way you can utilize this spreadsheet is if you actually want to drive a course to calculate your seeding rate. In this instance, I'm just using the haybuster drill again, the same target rate, but now instead of putting in the circumference of the drive wheel, you just put in 12 inches. So there's 12 inches in a foot. And for your number of revolutions, then you put the number of feet to drive. So 1 foot times 100 feet, that's a 100-foot length that you would drive. You put in however many tubes you're going to collect over that course. And then the spreadsheet will tell you that you need 196 grams on a 100-foot course with 6 tubes being collected. This is an example of the spreadsheet when it's actually printed out on a printer. The other shots were the actual spreadsheet on the computer. So there's plenty of white space that you can put some notes in here and try to keep it fairly straightforward in the format. I'm going to shift gears now and mention a little bit about some of the calibration principles and some things I've seen over time that might help your calibration go a little easier. As I mentioned earlier, the first thing you need to do is check the chart on the drill and look for something close to your seed, your target rate, and that gives you a setting to start with instead of just shooting in the dark. Then you need to set the rate mechanism for your target rate. I recommend on most of these rate plates, they're a slide of some sort, or in this case, it's a screw type mechanism. I always go past the number I'm shooting for and then come back to it because there tends to be a little bit of difference whether you're coming into a number or if you're coming back down to a number. And by coming back down to the number, that would be the maximum aperture at that setting. And I figure that's the least error. If you calibrate on the lean side and then you actually set it in the field from the high side, you could run out of seed before you get to the end of your field. Some of the tools that are helpful for running the calibration is some kind of a weighing unit. This is a scientific type scales. that are rather expensive, but you can get kitchen diet scales that will measure 10 pounds to the nearest gram, and easy to tear, easy to use in the field. And those you can pick those up for $20 to $30. Some kind of a bucket, this little red bucket works nice for that you can tear on the scales and then get your seed weight. Again, if you're going to do multiple calibrations or you're not going to leave the seed in the drill, then some way of cleaning out the drill. Again, I put this down here as a reminder that the iPad or a cell phone, if you can pull up the spreadsheet, you can actually put the numbers in and get your results right there as you're doing the calibration. I like to divide the drill into the sections. The John Deere drills and some of the other, and the Esch drills actually have metal dividers, so you have several chambers. I like to use a fair amount of seed when I calibrate. Some calibration videos talk about just putting a little bit over the port, but I feel that that weight, you need to establish flow to get an accurate calibration. So it's easy with these to have established plates. You just take some cardboard and put in there. In the hay buster, they don't have the individual sections, but it's not hard to cut some cardboard. It is important to note that they have a plate that covers the metering mechanism, and that plate must be in place to get an accurate rate determination. If you are going to calibrate and then seed at a later date, you'll want to clean out your drill, and these shop vacs work very nice for that. The other place this comes in handy is if you go to the trouble to set your drill up and you're going to do your calibrations in the shop, if you are going to use several different seed species or mixtures, then you can go ahead and put them in, run through your calibration, clean them out, and do the next seed while you're all set up for it. Another important part of the setup is you need to determine what the drive mechanism is for the seeding meter. These two at the top, the hay buster and the Esch, have a ground driven wheel that is independent from the machine wheels. When these are up in transport position, they're very easy to spin and measure and utilize for your calibration. The John Deere drill, the drive wheel for the rate mechanism is actually the machine wheel. So I found if you jack it up, block it up, you can use it to calibrate, but you need to make sure that that clutch mechanism is set so that it will deliver the seed. I usually take a 5-gallon bucket or a lawn chair and put back there so I can sit down while I'm spinning the wheel. It's helpful if you can mark the wheel so that you'll know when you get your complete revolutions. A little piece of duct tape works good. Some tires you can look and see the valve stem, and if you can see that easily, that works. Another important thing is make sure you're rotating the wheel in the right direction. So these two mechanisms are in the front of the seeder. So as you go forward, the wheel will be going this direction. So on these, you would pull the wheel toward you to run in the correct direction. For the John Deere, it's in the back of the unit. So that wheel is going to be spinning in this direction. So if you're sitting behind it, you would be pushing the wheel to have it run in the proper direction. It's relatively simple to get the circumference of the drive wheel. Usually a flexible tape wrapped around. I put a piece of duct tape on to hold it. So the end is actually right there. This one's about 5 feet 11 and a half inches. You would want to make sure you convert that to inches to put it into the spreadsheet. Another way of doing this, if you don't have a flexible measuring tape, is you can take a piece of string, wrap it around, and then measure it against a rigid tape. The other data you need to collect is the row spacing. You can do that with a tape and measure. In this case, I was doing the cultures because it was difficult to get to the opening, to the drop tubes. This one ended up being 2 feet 9 inches. And if you count, I'm starting on 1, then 2, 3, 4, 5, 6, 7. There's 7 coulters. Excuse me. But you actually would divide this by 6 because your effective planting width is halfway between these 2 coulters and halfway between the 2 on the right. So if you divide that 2 feet would be 24 inches plus 9, 33 inches divided by 6 coulters is 5.5 inch. And that drill is marketed as a 5.5 inch row spacing. The other thing to note on this Esch drill is they actually have a little hand crank on the wheel so that it's very easy to grab and spin, where the others you put your hands and have to turn it with your hands and fingers. To collect the seed, you may have to get a little creative. The hay buster is very easy. It has these spring clamps that you can take off with a piece of pliers, with a pair of pliers. Here you can see I've taken the 3 back delivery tubes off and put them in a 5-gallon bucket. And there's the next 3 tubes in another bucket. That was the 6 tubes that I was using in my calibration. I could have easily broken it down and done it as 3 tubes at a time. This was a technique that we came up with for the John Deere drill. It's very easy to remove the tubes up at the metering mechanism. The flexible tube where it clamps on to the openers, you need a screw clamp. It's a little more difficult to get to. And originally I was doing the John Deere drills with driving a course. And so we wanted something that would really hold on as that thing is bouncing through the field. I found that these landscape ties work very well. They're reusable, easy to unclamp. And then the second time we did it, the farmer said, well, why don't we cut the bottom of the bag? I've got a bunch of these clips. Then you just pull the clip and the seed drops right in a bucket, and it really sped things up. So I mentioned driving a course as a calibration technique. And here's an example of that. We just measured off 100 feet between the flags. You engage the drill at the starting point, and then you stop the drill at the end point, collect the bags or whatever you're using, and weigh them. The Rice Tech video for calibration actually uses styrofoam cups and sticks them up on there, and they seem to hold pretty good. That would be fine for a static calibration, but for doing the driving a course, I'd be a little leery that they might bounce off. Another point to note is most drills have more than one seed box. So if you have different mixes or different seed that you want to calibrate, you could actually run the calibration for each box at the same time. If you're going to the trouble of spinning the wheel, might as well get an extra set of buckets. So you could pull the drop tubes for the legume box and put them into one set of buckets, and then you could have another set of buckets for the large hopper. The hay buster actually has 3 hoppers. You've got the 2 large ones and the legume box. An example where you might do something like this would be if you're doing a planting of alfalfa and you want to use oats as a nurse crop. You put your alfalfa in the legume box, put your oats in the big box, and run the calibration simultaneously. This is just an example of the John Deere it's similar situation. You can pull the tubes for the legume box and keep them separate from the large box. And there at the bottom of the screen, you can see the flexible hose and how that's more of a muffler clamp type arrangement that once you get it off, it's pretty easy to use. It's just a little more tedious to pull it off and put it back on. Another point I like to make is that the metering mechanisms run the whole gamut. The hay buster is actually opposing diamonds. So as you increase that aperture, a small change in the number on the setting makes a big change in the seed delivery. So it's more of a geometric curve where the legume boxes and the John Deere use this fluted cylinder. And so when you change the rate, you're just putting more of the cylinder into the seed box, and it's more of a linear response. Again, in this lower picture, you can see the cylinder that's still outside of the seed box. And in this case, they've been running low rates. So dirt and grease has built up on the outside of the flutes. If you were going to do a calibration with a rather large seed at a heavier rate, you would want to make sure these things were clean to get a proper calibration. If you calibrated them with them in that condition, I would dare say your rate would increase as the seed cleans up the flutes. In the S drill, it's actually some foam plates that grab the seed and bring it down to the drop tubes. So you just want to make sure those are clean and soft and haven't been chewed up by mice or anything. So just take a good look at the drill as you're setting up and going through the exercise. The other thing I did here on this hay buster, I noticed as I was spinning the tire that seeds were popping out. They would overshoot the catch tube, and I didn't like that, so I put a little piece of tape so that all the seed would go through the tube and I would get it weighed. Something that I did have written on the spreadsheet and I forgot to mention was when you start your calibration, always discard your first run. It takes several revolutions for the seed flow to become established. And I recommend running an entire run. So if you're going to do 20 revolutions, do 20 revolutions, catch the seed and just dump it back in the hopper, then start doing your calibrations that you weigh. So those are some of the hints I have for calibrating a grain drill. If you have any questions, feel free to contact me at the information on the screen. I will be glad to review any of this information, and I can also be available to assist you with a calibration if I'm available and you'd like my assistance. So thank you.